This is problem number 3 in packet number 1, on the integration packets number 1. We're asked to express this range of numbers using sigma notation. Sigma notation can also be sometimes called summation notation. And the Greek letter looks like a fancy E, if you will, is representative of, it is sigma, it's the capital letter sigma, and it is representation of having a sum of a range of numbers. And that range of numbers is determined by what we put inside the parentheses that I've written here, as well as where we have our starting value and our ending value. Okay, we need to write what kind of term that we are summing up. So we need to give it a variable. Oftentimes you use I or you use J. I'm going to pick J. Since our numbers start at 2, well, then J is going to start at 2. When you use summation notation, you are using just integers for the values of J. Okay, you're incrementing by integers. So I need my end value is then going to be 13. And each of those numbers is just another integer. It's 1, it's 2, 3, 4, 5, up to 13. So all I'm doing is adding in values of J. The values, this notation says, take every integer value between 2 up to 13 and use those numbers. And put them into whatever function that is placed here. This is F in the same problem, number 3. And I've written down the problem. I've also highlighted that you have pairs of numbers that are the same. The 2's are the same, the 3's are the same, up to every term in the denominator and the numerator, and the next term's numerator are the same, right up to the last one from 99 to up to 99. So whatever we're going to use, whatever we're going to put into our function, the number has to be the same on, I have to have J on the top, okay, and a J on the bottom plus 1. If that makes sense to you, because the other piece of the puzzle here is that, oh, that's not a very good color, I can't see that very well. Okay. If you look in these values as well, the numerator is 1 bigger than the denominator. So that's what I've highlighted right in here. Now we need to figure out where J is starting. Well, if I just say that my beginning number is 1, that if we think about that, the first value being 1, I'd have 1 plus 1 over 1, which is 1 over 2. Try that again. Going to the second value of j, I'd have 2 over 2 plus 1, which is 3. Now let's go down. Let's go down to the very last term, the 9, and check to see if that works. Well, if j is 99, I'm going to have 99 over 100. So it's looking good. And in order to get j is 99, we have to put the 9 in the summation as the ending value. I'm just going to get you started on 3h, and the only thing that I'm going to point out on these terms, we are alternating signs. And the way you can deal with alternating signs in a summation notation is you're not, by multiplying by -1 raised to some power, okay? If j is an even, you're going to have your positive, and if j is odd, you'll be able to find your negative numbers.